Good morning, friends. I am S. HARIHARAN, Assistant Professor, Department of Mathematics, KSR College of Arts and Science for Women, Tirchangur. In this video, we are going to discuss about what is meant by OR and what are the applications of OR in our real life one by one. First, let us see introduction. In this session, what is OR? That is Operations Research. How is it is used to solve real life everyday problems and LPP introduction. What is OR? Operations research, that is OR, is the application of mathematical methods to tackle real-life problems associated with decision-making in businesses and other enterprises. The application of maths in the real world. OR is the maths used in supermarkets, like understanding people's buying pattern, determining the number of staff needed on checkout and at what times. OR is the maths used in sport. For example, Formula 1 pit stop strategy, scheduling football game, designing a stadium. OR is the maths used by airlines, that is calculating the number of staff required at check-in and bag drop desk, scheduling the cabin crew, setting the prices of tickets to reflect changing demand. When is OR used? Optimization is a way to solve problems in which one seeks to achieve the best outcome. Simulation allows you to try out different approaches by simulating events numerous times and answer the what if question. Queuing theory is used to approximate a real queuing situation or system, so the queuing behavior can be analyzed mathematically. Uses and limitations of OR. OR is useful for solving resource allocation problems, inventory control problems, maintenance and replace problems, sequencing and scheduling problem, assignment of job to applicants to maximize total profit, transportation problems, shortest route problems like traveling salesperson problems, marketing management problem, finance management problem, production planning and control problem, designing problem, and queuing problem. Linear programming problem. Both objective function and constraints are linear. Solutions are highly structured and can be rapidly obtained. That is linear programming problem. Shortly, it can return as LPP. So, LPP has any type of LPP has three components. The very first one objective function, second one constraints part, and the third one non-negativity restrictions. The objective function, it may be positive, it may be maximize or minimize. Constraints parts, it may be less than or equal to type or greater than or equal to type or equation. Non-negativity restrictions, that is the all unknown variable must be 0 or positive, either integer or fraction value. These three components are most important in each and every LPP. Requirement for employing LPP technique. There must be a well-defined objective function. There must be alternative courses of action to choose. At least some of the resources must be in limited supply, which give rise to constraints. Both the objective function and constraints must be linear equations or inequalities. Mathematical formulation of LPP, that is already we discussed. If or the n decision variable of the problem and if the system is subject to m constraints, the general mathematical model can be written in the form optimize z, that is that z it may be maximize or minimize. So f of x1, x2, x3 etc. xn and subject to gi of x1, x2, x3 etc. xn, it may be less than or equal to or greater than or equal to, and bi equal to 1, 2, 3 etc. m called structural constraints, and x1, x2, x3 etc. xn greater than or equal to 0 called the non-negativity restrictions or constraints. So any type of LPP we can solve. There are different methods, that is graphical solution, simplex method, big M method, two-phase simplex method, dual simplex method, and so on. So in graphical method, there are only two unknown variables are available, and the constraints part, it may be less than or equal to or greater than or equal to or equal to. But in the simplex method, there are more than two unknown variables are allowed, and the constraints part, it must be less than or equal to type. Then only we can apply simplex method. Otherwise, we cannot apply simplex method and we go to another method. Name of that method is called big M method or artificial technique. In this method, In the objective function, it may be minimize or maximize. In the constraints part, it the mixed component, that is like it may be less than or equal to, or greater than or equal to, or equal to. And in the non-restrictive, non-negativity restriction, it must be greater than or equal to 0. Then we have to apply Bingham method or artificial technical method. Another name is penalty corner method. Thank you.